Hello guys, how are you all? I hope you all are fine. So you are very welcome in a lecture number 4 of areas of parallelograms and triangles. Okay, so I hope you will enjoy this lecture. Okay, so now let's start without wasting the time. Yes, so here is today we are going to discuss about a parallelogram and a triangle between the same parallels. Okay, now in this case we have a parallelogram and a triangle on the same base and between the same parallel. Okay, so now a triangle and the parallelogram are said to be on the same base and between the same parallels if once again we have two conditions. Like, what are these? So they have a common side. This is the first condition, and the second is the vertices opposite the common side lie on a straight line parallel to the common side, okay. So now you can see the figure here is, so in this, my dear friends, here is we have a figure, and in this there are two figures. What are these? So first figure is, this is triangle ABC. You can see like this, you can see, okay. And again the second figure is ABDE, which is what? Which is a parallelogram. ABDE is what? It is the parallelogram. So we can write here is, in this figure we have a triangle ABC, okay, and a parallelogram ABDE. Here we can write as, common base. Common base is AB, okay, and the same parallels are what? Same parallels are AB and ED. Means these two lines are, yeah, same parallels. Okay, I hope you get this point. So now let's see the theorem on this topic. So here is, now if a triangle and a parallelogram are on the common base and between the same parallels, then the area of the triangle is equal to the half of the area of the parallelogram. Half of the area of the parallelogram. Okay, so now here is, so there are two methods to prove this theorem. Okay, so now first of all we are going to see the method 1. Okay, now we have a figure like this. Okay, we have a figure like this. So now in this you can see that we have a parallelogram A, B, C and D. So this is what? This is the parallelogram. Okay, and we have a triangle you can see, this is the triangle ABP. This is the triangle. So we can say that the common base is what? The common base is AB. Okay, now if we join CD at point P, if we produce DC which intersect at point D, then we can say that PC and AB are the what? Same parallels. Okay, I hope you get this point. So now here first of all we have to write the given part. Yes, so the given part is, we have a parallelogram ABCD, okay, and a triangle ABP and a triangle ABP on the same base. So we can write same base is AB. Same base is what? Same base is AB, and between the same parallels. Okay, so same parallels is what? Same parallels is A, B and PC. Okay, I hope you get this point. And we have to prove area of triangle ABP is equals to half of the area of parallelogram ABCD. ABCD. Okay, I hope you get this point. So now first of all we have to construct it. Okay, we have to do a construction. So here is first of all join DP. Okay, this is the construction part. Okay, and we have to draw PN which is perpendicular to AB, and we have to draw DM which is also perpendicular to AB. So here is the construction part. So construction is join DP and draw PN which is perpendicular to AB and DM which is also perpendicular to AB. Okay, I hope you get this point. So now let's start to prove this theorem. Yes, so now here is, my dear friends, you can see. So first of all we are taking the parallelogram ABCD. So we are writing as for parallelogram ABCD. Here you can see that DM is perpendicular to what? DM is perpendicular to AB. Okay, and here in this case height is what? Height is DM, and the base is what? Base is AB. Base is AB. So we can write here as, since DM is perpendicular to AB, so we can write it by construction. By what? By construction. Okay. Okay, so now we can say that here is height is what? Height is DM, and base is AB. Okay, and we know that what is the area of parallelogram? So the area of parallelograms is base into height. So here is area of parallelogram ABCD. This is what? Base into height. So here is base is what? AB into height is DM. Height is what? Height is DM. Okay, so let's suppose this is equation number 1. Okay, now we are taking the triangle what? PAB. So for triangle PAB, here is, we know that since PN is perpendicular to AB, here is, this line is perpendicular to AB, so we can write it as by construction. Okay, got it? And base is what? So from this we can say that base is AB and height is PN. Height is what? PN. So we know that what is the area of any of the triangle? Half into base into height. So we can write here as area of triangle PAB is equals to half into base into height. Base into height. So half into base is what? AB into height is what? Height is PN. Okay, my dear friends, I hope you understand these things. So this is what? This is the area of triangle PAB. Yes, so now my dear friends, here is, we know that opposite sides of a parallelogram are equal, means here is AB and DC are equal, and we also know that opposite sides are parallel also. Okay, means AB is parallel to DC. Okay, and as distance between the parallel lines are equal, it means we can say that DM is equals to PN. DM is equals to PN. Okay, so here is we can write, since AB is parallel to CD, this is what? Opposite sides of parallelogram. Okay, so we can say that here is Pn is equals to dm. Pn is equals to dm. Okay, because distance between parallel lines are equal. Parallel lines are equal. Okay, I hope you get this point. So we can write here as dm in place of pn. So let's suppose this is equation number 2. Okay, I hope you get this point. So now, yes, so we can write here is in equation second, we can write area of triangle PAB is equals to half into AB into DM. Half into AB into DM. Okay, so let's suppose this is equation number 3. Now from first and third, here if you compare this, now in this is what? AB into DM. Okay, and here is AB into DM. So we can write in the place of AB into DM is area of parallelogram ABCD. So here is area of triangle PAB is equals to half into area of parallelogram ABCD. Okay, I hope you understand these things, my dear friends. So this is the result. This is the required result. So we can write here as and proof. I hope you understand these things. So this is the method to prove this theorem. Okay. Yes. So now here is the method number 2 for solving this, for proving this theorem. So here is again we have a figure like this. You can see, and in this we have a parallelogram A, B, C, D. Okay, and we have a triangle PAB. Okay, again these two figures means parallelogram and the triangles are on the same base AB and between the same parallels, which is AB and PC. So again, first of all, write the given part. So what is the, so here is we can write it as we have a parallelogram ABCD and triangle PAB. Okay, and these two figures are on the same base. So what is the same base? So same base is AB and same parallels are what? AB and PC. Okay, got it? Now we have to prove. Here is you can see area of triangle is equals to half of the area of parallelogram. Means area of triangle ABP is equals to half of the area of parallelogram ABCD. Okay, means the area of this triangle, okay, and the area of this parallelogram. This is what? Yes. So the area of triangle ABP is equals to half of the area of parallelogram ABCD. Okay, I hope you get this point. Yes. So now let's start to prove this theorem. So here is the proof. So in parallelogram, parallelogram ABCD. Here is, we know that AB is parallel to DC. Okay, because we know that opposite sides are parallel to each other, so opposite sides are parallel to each other, okay, got it. So now here is, we can say that also PC is also parallel to AB, okay, because parts of parallel lines are parallel, so we can write it as, so PC is parallel to AB because parts of parallel lines are parallel, okay, got it. Now we have to draw a line, BQ, okay, which line? BQ, which is parallel to PA, so we can write as draw a line BQ, okay, draw a line BQ which is parallel to AP, means BQ line is parallel to AP, okay, that is, we can write as BQ is parallel to AP. BQ is parallel to AP, got it. So now here is, we can say that here is BQ is parallel to AP. So this figure A, B, Q, P. In this figure, one pair of opposite sides are parallel. So here is, we can write it as, so now here is, we can write, since BQ is parallel to AP. Okay, now we know that here is this PC is equals to AB, so we can say that this PQ is also equals to AB. So we can write, and PQ is parallel to AB because here is, we know that as PC is parallel to AB. Okay, so parts of parallel lines are what? Are parallel. Okay, so in this, we can say that in the figure ABQP, both pair of opposite sides are parallel, so we can say that ABQP is what? This is parallelogram. So we can write both pair of opposite sides are parallel. Both pair of opposite sides are parallel, so we can say A, B, Q, P is a parallelogram. Is what? Is a parallelogram. So my dear friends, I hope you understand these things. So now here is, we can observe that A, B, C, D and A, B, Q, P, they are what? They are the parallelogram, okay, and these parallelograms are on the same base AB and between the same parallel lines AB and PC. So we can write here as parallelogram AB QP, okay, and AB CD are on the same base AB and between the same parallel lines, so which are AB and PC. Okay, my dear friends, I hope you get this point. So we can say that by the theorem 9.1, that we can say area of parallelogram ABQP is equals to the area of parallelogram ABCD. Yes, so now my dear friends, we can say that area of parallelogram ABQP is equals to area of parallelogram ABCD, because parallelograms with same base and between the same parallel lines are equal in area. We also proved this in theorem 9.1, means in previous lecture. Okay, yes, so we can write the reasons. What is the reason? Parallelograms with same base and between the same parallel lines. Same parallel lines are equal in area. Okay, got it? Now let's suppose this is equation number 1. Okay, now here is, now in parallelogram ABQP, in this parallelogram ABQP, here you can see in parallelogram ABQP, here is, you can see BP is the diagonal. BP is what? BP is diagonal. BP is what? BP is the diagonal of ABQP. Okay, so triangle ABP is congruent to triangle QBP, because we know that diagonals of a parallelogram divides it into two congruent triangles. Okay, we already learned in the previous chapters. Okay, so here is, we can write it as, because diagonals of a parallelogram divides it into two congruent triangle. Got it? Yes, so we can say that the area of triangle ABP is also equals to area of triangle QBP. Got it? Yes, so we can say, so area of triangle ABP is equals to area of triangle QBP. Okay, because area of congruent triangle is equal, we can write area of congruent triangle is equal. Okay, got it? Now here is, we know that area of triangle ABP, which is equals to area of triangle, here is area of triangle BPQ. Okay, which is equals to half of the area of parallelogram AB, which is the half of the parallelogram ABQP, because diagonal PB divides the quadrilateral or parallelogram ABQP into equal areas. Okay, so we can write here as area of triangle ABP is equals to area of triangle QBP. Okay, which is equals to half of the area of parallelogram ABQP. Okay, got it? Yes, so we can write area of triangle ABP, okay, which is equals to half of area of parallelogram ABQP. ABQP. Okay, now here is, we know that area of ABQP is equals to the area of parallelogram ABCD from equation 1. Here is from equation 1, there is area of parallelogram ABQP is equals to the area of parallelogram ABCD. So we can write here as, so this will become area of triangle ABP is equals to half of the area of parallelogram ABCD. What is ABCD? So we can say that this is a required result. Required result we can write and prove. I hope my dear friends you understand these things. So these are the two methods to prove this theorem. Okay. Yes. So now let's solve some problems. Okay. Yes. So here is, now in figure, P is the point in the interior of the parallelogram. P is what? P is the point in the interior of this parallelogram ABCD. Okay. Now show that area of triangle APB plus area of triangle PCD is equals to half of the area of triangle ABCD. And in the second part, area of triangle APD means this area of triangle, plus area of triangle PBC means this, is equals to area of triangle APB means this, plus area of triangle PCD. Okay. Now here is, we have a hint. Through P, draw a line parallel to AB. Now we have to draw a line from point B which is parallel to AB like this. Okay. I hope you get this point. Yes. So now let's start to solve this problem. Okay. Yes. So now here is, so now let's start to solve the first part. So here is, we have to prove area of triangle APB. Okay. Means APB means this part, and the second part this. Okay. Means area of triangle PDC. The sum of these two triangles is equals to half of the area of parallelogram ABCD. Okay. Now let's start. So first of all, we have to write the given part. So what is the given part? So here is, we have a parallelogram ABCD. Okay. And we have to prove area of triangle APB plus area of triangle PCD is equals to half of area of parallelogram ABCD. Okay. Now here is, we are going to start the proof. So since we know that ABCD is what? This is the parallelogram. So here is, we can write AB is parallel to DC. Okay. And AD is parallel to BC. So we can write here as, these are the opposite sides, and we know that opposite sides of parallelograms are parallel. So opposite side, you have to be write the reasons of every of these steps. Okay. So whatever you are doing, you have to be write with the reasons. Okay. So that's why I'm writing the reasons again and again. Okay. So you have to make any habits. So opposite sides of parallelogram are parallel. Okay. Now we are drawing a line. Now let's draw a line. Here is EF. Okay. From passing from point P, EF is a line which is parallel to AB and DC. Okay. So here is, draw a line EF passing through point P, and which is parallel to AB and DC, which is parallel to AB and DC. So we can write here as, that is, EF is parallel to AB and also parallel to CD and also parallel to CD. Got it, my dear friends? Yes, now my dear friends, here is, since we know that AD is parallel to BC, so we can say that AE is also parallel to BF. Okay, is also parallel to BF. Okay, so here is, we can write it as AE is parallel to BF, because we know that as AD is parallel to BC. Okay, and parts of parallel sides are parallel. Parts of parallel sides are what? They are parallels. Okay, and we also know that AB is parallel to EF by construction. So here is, we can say that the opposite pairs of this quadrilateral AEFB are parallel. So we can say AEFB is what? AEFB is what? Okay, so we can say that AEFB is what? This is parallelogram. So here we can write, here is, since AEFB is parallelogram, as both pair of opposite sides are what? Are parallel. Okay, my dear friends, I hope you get this point. So now here is, similarly, we can say that EFCD is a parallelogram. Similarly, we can also say that EFCD is what? Parallelogram, because here is, we know that EF is parallel to DC by construction. Okay, and we know that AD is parallel to BC and ED is also parallel to FC, because we know that parts of the parallel sides are parallel. Okay, so here is again opposite sides, again both pair of opposite sides are parallel, so we can say that EFCD is the parallelogram. So I hope you understand these things. So now here is, now in triangle APB, in this triangle, okay, and parallelogram EFBA, means this parallelogram. Okay, here is, we know that these two figures are on the same base and between the same parallel line, so we can say that here is triangle APB and parallelogram EFBA are on the same base, AB, and between the same parallel line, AB and EF. Okay, got it? So we can say that since area of triangle APB is equals to half of the area of parallelogram AEFB. Okay, let's suppose this is equation number 1, because here is, we know that area of triangle is half of the parallelogram if they have the same base and same parallel lines. Okay, I hope you understand these things. So we can write here as, we can write by theorem. In short, by theorem 9.2. Got it? Yes. So now similarly, here is triangle PCD, this triangle, okay, and parallelogram EDCF, parallelogram, yes, EDCF. So these two figures again, a parallelogram and a triangle are on the same base, which is DC, and between the same parallel lines, which is EF and DC. So similarly, we can write again triangle, here is triangle PCD and parallelogram EFCD. This is what they are on the same base. Same base is DC, and between the same parallel lines, which is same parallel lines are what? DC and EF. Okay, so we can write again, since area of triangle PCD is equals to half of the area of parallelogram EFCD. Okay, again we can write by theorem 9.2, and let's suppose this is equation number 2. Okay, I hope you get this point. Yes. So now if we add these two equations, here is, if we add equation number 1 and equation number 2, here we get add equation 1 and 2. Here is, so we get area of triangle APB, okay, plus area of triangle PDC, which is equals to half of the area of parallelogram EFAB plus half of the area of parallelogram EFCD. Okay, now here if you observe this, if we add this part and if we add this part, so we get this whole part. Okay, so here is, we can write area of triangle APB plus area of triangle PDC. So this is equals to half of the area of parallelogram ABCD. So we can write here as hence proof. We can write what? Hence proof. I hope, my dear friend, you understand these things. So this is the proof of the first part. Okay, so now let's come on to the second part. Yes, so now in the second part, we have to prove area of triangle APD means this, area of triangle APD means this triangle, plus area of triangle PBC, means this triangle, is equals to area of triangle APB means third, this is triangle, and plus area of triangle PCD means this triangle, fourth triangle, means we have 4 triangle, 1 2 3 4. So area of 1 plus area of 2 is equals to area of 3 plus area of 4. So we have to prove like this. Okay, yes. So now let's start to prove this. Yes. So again, first of all, we have to write the given part. So the given part is, we have a parallelogram ABCD. Okay, now in this, okay, and we have to prove what? Yeah, so area of triangle APD plus area of triangle PBC is equals to area of triangle APB plus area of triangle PCD. Okay, now let's start to prove this. So we know that, my dear friend, here is area of triangle 3 plus 4 is equals to half of the area of parallelogram ABCD. Okay, now here is, we know that, now these 4 triangles, if we add these 4 triangles, we get the area of this parallelogram. Okay, so if we add the area of these triangles, like area of triangle APD plus area of triangle APB plus area of triangle BPC plus area of triangle, here is PCD. Okay, so this is equals to what? This is equals to area of parallelogram ABCD. I hope you understand these things. Yes, now here is, now this part, area of triangle APB, okay, plus area of triangle PCD from previous part. Okay, we know that here you can see that area of triangle APD plus area of triangle BPC plus, here we can write half of the area of parallelogram ABCD. Okay, and this is equals to what? Area of parallelogram ABCD. So my dear friends, I hope you understand these things. Yes, now if we shift this term to RHS side, here we get area of triangle APD plus area of triangle BPC. We get, if we subtract this, here we get half of area of parallelogram ABCD. Got it? Now we know that here is, let's suppose this is equation number 2. Okay, now from this equation, let's suppose this is my equation number 1. Now from this part we can compare the RHS side. Both equations have the same RHS, so we can write from 1 and 2. Okay, we can write area of triangle APD plus area of triangle BBC is equals to, okay, is equals to area of triangle APB plus area of triangle PCD. Okay, my dear friends, I hope you understand these things. So this is what? This is the proof of this second part. Okay, and we can write hence proof. Okay, I hope my dear friend you understand these things. Yes. So now this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.